Wheelchairs provide a form of transportation for people with cognitive or motor disabilities and impairments, providing integration into everyday life. During this video, we will explore the basics of wheelchairs, including proper fitting as well as positioning and forces in propulsion.
Ideal positioning for the body in a wheelchair has the center of mass as close to the main axle as possible. This decreases rolling resistance, decreases downhill turning tendency, and increases propulsion efficiency. A way to check the center of mass location is to see if relaxed arms align closely with the main axle. This places the shoulders over the axle, allowing the greatest range of motion during the stroke. You can see the horizontal shoulder positioning is proper in this situation. The gap between the driving wheels and the torso should be as narrow as possible to allow maximum propulsion efficiency, and keep the arms in a more neutral position, which decreases strain on the upper extremities. Here you can see an example of a wheelchair that is too wide for the user.
The propulsion cycle is composed of the push phase and recovery phase. The push phase can be broken into flexion and extension. First, the user grabs onto the rim behind the axle. The biceps and brachioradialis power the flexion portion of the push phase. Next, the triceps extend and the anterior deltoids flex to complete the push phase. Following this, the user returns its hands to the first position. This is called the recovery phase, which uses the posterior deltoids and triceps.
Due to the high forces, low propulsion efficiency, and repetitive nature, upper extremity pain and injuries are common. The location could vary depending on the user's activities, and their positioning in the wheelchair. Different locations could include the wrist, elbow, biceps, and shoulder, particularly the rotator cuff. One such cause of these injuries can result from the force in the shoulder changing directions from the start of the push phase to the end of the push phase. Increasing the force at the end of the stroke can increase the likelihood of strain, as well as cause the user to become unstable and do a wheelie.
Although there have been improvements in wheelchairs throughout history, there is still need for applying advancements in the field of biomechanics to increase the physical capabilities of wheelchair users.